Okay, let's go over some stuff. So what is a log? I want you to think of the log as sort of the reverse of an exponent. Okay? Or really, we should say an inverse of an exponent. So log base 3 of 1/9, we're going to rewrite that as an exponential to evaluate it. So that's why it's important to remember it's the reverse of an exponential. So to rewrite this as an exponential, remember, log means like what is the exponent or the exponent of the base 3. So I'm going to write this. I'm going to rewrite this as the exponent of the base 3 that equals 1/9. That's how we can figure out what that is. Instead of a question mark, I'm going to start using an x here, right? And I want to know what x is. Well, I know it's got to be negative. I shouldn't say equals here. I know it's going to be negative, so I'm going to say log base 3 of 1/9 is equal to a negative. Now, 3 to what power would be 9? 3 squared, so it's -2. So that's how we can figure it out. We can rewrite it in exponential form. Okay, this one says, what is the exponent of the base 4 that equals 1? Well, we know that anything to the 0 power is 1, so that answer is 0. 4 to the 0 is 1, right? That's the exponent I would put here, 0. Here the exponent would be -2. Sorry for the video in here. Yeah. All right, so this one, I'll rewrite it as, what is the exponent of 2 that equals 2? Well, that answer is just going to be 1, right? So we could say log base 2 of 2 equals 1. So you could think of like there was already an exponent here. This is an important one. When the base of that log matches the base of that number inside there, something special happens and they're just going to cancel out. So this one, let's look at this. This one doesn't seem to have a base. That's called the common logarithm. If you don't see a base there, that means we want it to be 10. We just don't write it. That's called the common logarithm. So this would be 10 to what exponent equals 100? Well, that would be 2. So I could say log of 100 equals 2. All right, here's that special case again. Notice the base of the log matches the base of this thing inside here. So they're just going to cancel out, and that answer will just be 4. That's like a special case. Let's write it out to see, though. Log base d means what is the exponent of base d that would equal d to the 4th? Well, that means it's going to have to be 4. So we could say log base d of d to the 4th equals 4. All right, so here's another one where the log of the base matches the base inside here. So those are just going to undo each other, and the answer is going to be 10. Here's log base 10 of 1. Well, anytime we have the log of 1, it always equals 0 because anything to the 0 power equals 1. It doesn't matter what the base is here. This base is 10, but it could be any base, like not just 10. It could be 2. If it's any base, log of 1, I should say this way. If we have log of 1, it could be any base. It will always equal 0. So this one here is also 0. All right, now the other skill we had was rewriting in exponential form. So let's take this log, and we're going to maybe use some of this today. Let's take this log and rewrite it in exponential form. So remember, if there's no base on the tail of the log, it's like a 10. We mean it to be 10. So we would say the exponent of 10 is x, because remember, a log is an exponent. So equals is like is. So it's 10 to the x equals 5. Sorry. Rewrite this one, log base x, that means what is the base of, what is the exponent of the base x? Well, the log is the exponent, so x squared equals 9. That's how I rewrite that one. And this one, what is this ln? We've never seen that before. That's crazy. So that's a special kind of log, or a log with a special kind of base. And that base is the number e. That is a number just like pi. We'll look into what this number is and where it comes from a little more closely another lesson. All right, so natural log, you can think of it as log base e. So, so if we rewrite this, it's going to say the exponent of the base e is 4, and then that's equal to x. This last one here says, remember this is like a log base e. So it's going to say the exponent of the base e is whatever it's equal to is the exponent. So the exponent of the base e is y, and that's equal to e squared, because that's what I had there. So that's how we rewrite those as a reminder. Now, rewriting exponentials in terms of a logarithm, I always start with writing log, and then the base. Remember, in an exponential, this is the base, and this is the exponent. So I always write the log, and then at the tail is where we write the base. So that's like base 4 of something. I'm going to skip over that, is -3, because remember, the log is the exponent, and the equal sign is like our is, and the exponent is -3. And then I put the other thing in here. Okay, so this one I'm going to write log, and the base is 9 of something is 1/2. The exponent is 1/2. The log is 1/2. The log equals 1/2. And then the 3 goes in there. This one, oh, we have that special number e for the base, so we don't write log base e. Mathematicians use a shorthand because we use this log a lot also. It's called the natural log, and we write ln. Of something is the exponent x, right? X is the exponent, so the log is the exponent, and then we say of 4. And then lastly here, we'll say log base 5 of something is the exponent, which is x. Oh, wait, I messed that one up. It's log base 7, right? Because the base is here. I switched the equation around. So log base 7, and so the exponent of base 7 is x. That's how I write that, and then I put the 5 in there. Okay, thank you.